Hey guys, we're back with the second part of the video, and if you recall, the next thing that we need to do is actually to draw a graph to help you visualize the relationship. So let's say you have your readings for your IV and your DV. In this case, you would have to do a calculation to calculate this, because eventually the question asks you to plot a graph between this and this. So let's go and look at the graph paper. So the first thing you need to know is that you can draw your graph in portrait or landscape, but yeah, in this case I've decided to choose portrait to draw it in. The next thing you need to know is that when you draw a graph, that your axis can not go 10 small boxes away from the side. So that means I cannot have it here or here or here. Alright, so my axis can only be from here to here. The same goes with the x-axis. From the bottom, I cannot go too far up. Right, this is to prevent your graph from looking way too small. So in the question, you're supposed to plot this IV versus this DV. Alright, this IV is part from what you calculated. You change here and you calculated this, so this now becomes your independent variable. And this becomes your dependent variable. So you need to plot. The next thing you need to know is that your IV, your independent variable, always goes on the x-axis, and your dependent variable here always goes on your y-axis. Alright, the very first thing, in this school actually we use something called SPCAG. So what you need to take note, the very first thing for S is your scale. The purpose of your scale is to ensure that your graph does not look small. Alright, you do not want your graph looking very small. There have been students in the past few years who have drawn their graph in this size. That means they only utilize this small portion, about a size of 2 boxes and more boxes. That means they use a scale in such a way that all their plots are all over here, and then they draw a straight line, and then this is the exact size, and then they pass up. So no, wrong. The thing that you need to know is that for your scale, you must select one that will allow your graph to be as big as possible. That means utilize the whole area of your graph paper. Next, the increment for every box, every 10 boxes or 1 cm length here, must be in increments of 1, 2, or 5, or its corresponding decimal places. So it can be 0.1, can be 0.2, can be 0.5, can be 10, 20, or 50. That is depending on what your readings are. Alright, so for example, let's try and find a suitable scale for this. This is your dependent variable. Remember, your dependent variable goes on your y-axis. So I can choose to start from 0, of course, because naturally you learn in math that you always start your graph from 0. So that means to fit all my readings, I should start from 0, 1. Every increment should be 1 cm. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my reading here will be the 9 cm. Alright, the problem with this, this is perfectly fine, but the problem with this is that actually then your graph might not be very big, because one of the requirements is that your graph must occupy at least 50% of the graph paper. So if you do this, you might not be able to occupy. So let's just say you decide to use 0 to 9, and if you do this, you have a reading from 4.4 to 9.3. So let me just count 0, 1, 2, 3, 4. So 4.4 is somewhere here, and 9.3 is somewhere here. So if you were to do your first reading is here and your last reading is here, you are only utilizing about 1, 2, 3, 4, about 4.5 boxes. Alright, so if you were to look at the whole length of the graph paper, there's actually 12 boxes. So this does not meet the requirement for 50%. So the next thing that you need to unlearn is that actually you do not need to start from 0. So if you do not need to start from 0, so a suitable scale would then be actually starting it from about 4, because that's what my smallest reading is. So aim to have your first reading to be as close as possible to this axis here, and to have your last reading of 9.3 to be as high up as possible over here. So that's your aim. Start here and end here. So I would try to start from 4. Then I'll just figure it out. I try 4.5, 5, 5.56, 6.57, 7.58, 8.59, 9.5. So my last reading here is actually 9.5. So then you realize that actually, hey, My first reading is 4.4. It's around somewhere around here. My last reading is actually 9.3, somewhere around here. So then I utilize almost the whole entire length of this graph paper. So you do that the same for your independent variable, which is supposed to go on your x-axis, and you will get a good scale. Just remember that every increment must be 1, 2, or 5. So that's the most important thing that you need to take note of. Alright, the next thing that you need to take note of, or the points, or P, is actually the points plotted. So make sure that whatever readings you have here, you plot them accurately and you will get this mark. Alright, the next thing you need to take note of is, sorry, I'll review the G here, but it's axis with label. So whatever you have on your table, the heading, make sure that you copy it down. In this case, my IV is 1 over X, and the unit is per centimeter, so make sure that it follows. Draw an arrowhead. Okay, right, 1 over X followed by the unit per centimeter. Alright, I know it's a little bit ugly. I'll show you a nicer one when we're done. Alright, it's a bit laggy. Then follow the same with dV. Remember, you must have your arrowhead and then followed by your quantity followed by your units. Alright, so after you've settled your scale, your axis, and then you plotted your points, the last thing you need to note is your best fit curve. Alright, your curve and line of best fit must follow a few things. 1. You must cut through as many points as possible. So if, say, I were to have 6 points plotted here and they all follow a nice graph, let me just draw a few points here. Here, 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 here. So let's say I have these few points here. Okay, let's say I have these few points here. If you are able to find the best fit line that will cut through all the points, then, well, you're done. You have this requirement done. The next thing, if you cannot have this happen, and in usual experimental cases, this is not possible for it to happen, you need to try and cut as many points as possible, and at the same time have equal amount of points above and below the line. So let's say you have 1, 2, 3, 4, 5 points only. If I'm able to cut to 3 of them, and then I have 1 point above and 1 point below, then yes, that is the best fit line. The last requirement is that if, let's say, you cannot have, or you have very little points that you can cut through, you need to try and minimize the distance between the points and the line. So that means your best fit line cannot be something like this. I cannot say that, hey, I cut through this point, I have 2 points above the line, I have 2 points below the line. This is a best fit line. No, this is not a best fit line. Alright, you need to make sure that the distance between this point, this line, and all the points are as small as possible. So if you are able to meet all of this, then you have yourself a best fit curve or line. So I'll just show you what the best fit curve or line is, what it looks like, and then just for you to take note, the very last thing you need to take note is your gradient. Your gradient, after you have drawn your graph, you need to draw your calculate your gradient, and then I'll show you in the next portion of the video how to calculate your gradient. Hey guys, I finished drawing my graph. So this is what my graph looks like. Alright, so just a few other points for you to take note. One is that all your points, you should plot them using an X. Make sure it's not too small, make sure it's not too big, about this size is alright. Alright, and then the next thing, if you notice, is that, let me zoom in a little bit. If you notice, I have my axis with my label, my A, in your SPCAG. My scale is a good scale because my first point is here and my last point is all the way over here. I'm using as much of the graph as possible. So according to the y-axis, I'm using enough points. If you look at the x-axis, my first point is here, my last point is all the way somewhere around here, if you look up. So I'm using almost more than 50% of the graph paper, so my scale is good. Just take note also that my scale, every 10 boxes is 1, 2, or 5. In this case, it is 0.5 cm. In this case over here, it is actually 0.2 cm. Every 10 boxes represents 0.2 cm, so it falls within the 1, 2, or 5. Alright, the next thing I want to show you is your best curve or line of best fit. So let me zoom out a bit. Your curve and line of best fit, if you remember, there are three things that you need to take note. I try to cut through as many points as possible. After that, I ensure that I have an equal number of points above and below, and then finally um, minimize the distance between the point and the line. So if you look at this, this is a best fit line because I've cut through 2 points here, one here and one here, and then I have 2 points above and below, one, two below, one, two above. So this is a line of best fit. So I've done my scale, I plotted my points, remember using the X, I have a curve and line of best fit, and then I have an axis. My axis has my label here. Alright, the next thing you need to take note is gradient. How do I show gradient? You need to select correct points for your gradient. Your gradient points that you selected, you need to select 2 points on your line basically for gradient. The points that you selected cannot be one of the plotted points, even though it exists on the line. Alright, and then the other requirement for your plotted, for the selection of your gradient point, is that you must select a point that is just nice on an intersection of the box here. So if I were to select, say, all the points look quite good. If I were to select this point, let's say I want to select this point, this is not a good point on the line because it is in between the boxes. I can't tell exactly what the reading is. So select the point that lies directly on the intersection. Just put a little dot here so that I can see. After you put a little dot, label the X and Y coordinates. Alright, the other thing you need to take note for your gradient is that also you need to select your gradient points as far away as possible. So I selected one here near the end of the graph, and I need to select another one here. So again, the same thing happens. I select a point that on the line that cuts through the nice point of intersection. This is not a good point for me to select. Neither is this one, neither is this one, because it lies in between the box. So I selected this point, I label the X and Y coordinates, and then once I have these two, I draw a gradient triangle. Alright, not very clear, but you can see that I draw a gradient triangle here and here. So once you've drawn the gradient triangle, if your job is that you are required to find gradient, then use this formula: y2 minus y1 over x2 minus x1. Substitute in the values. You should know this gradient formula from math. Your calculated value to 3SF. So once you've done all this, then you basically have drawn a good graph. Alright, that brings us to the end of your sparse scale 1 and 2 video. So the few things that you need to note to summarize: first, when you are trying to find a relationship, and then you record your data in a table. This table will not be given to you in a SPA. You have to make your own. So the how you record, you use HNPRA. Ensure that your heading, number of readings, precision, your range, and the accuracy of the experiment is good. And finally, once you have your reading, remember all the things you need to do to draw a good graph. SPCAG. Alright, so your scale, your points plotted, your curve of best fit, your axis, and finally your calculation of your gradient. So your calculation of your gradient should go in the foolscap, which you draw your table, and then finally after you've drawn your after you calculated your gradient, then you write your conclusion statement. Remember this, I covered this: linear, non-linear, positive or negative gradient. And then finally you are supposed to comment on sources of error. So that's all you need to know about sparse scale 1 and 2.